Alright, so this problem is on mesh analysis, which is another cool way of solving some of these new circuits that we're getting. So let's draw this out. We get a positive and negative. We've got a resistor. We've got a resistor. Resistor. Back around. Got a resistor. Got a resistor. Got a resistor here too. And let's put values in. 18, 6, 2, 4, 2, 4, 4. Alright, so this is our circuit here. So, it is asking what the currents through different parts of the circuits are. So, let's check. Let's step back first. There are a couple ways to solve this. So previously, one totally legitimate way to solve this is to add this up with the total resistance, and then V equals IR to get the total current coming out of here, and then a voltage divider to split this. However, if you notice, this is a delta Y circuit, or more specifically, it's a Wheatstone bridge if you look at it, because look, this side is balanced with this side. And because this is equal, that means the current splits equally here and equally here. And if current's equal here and equal here, nothing's going to go back and forth. This is zero. So we can just look at this. Sometimes you can look at these circuits and you can see, but the current going through this 4 ohm resistor is zero. There's no heat. There's nothing happening here. Okay? So that's just one thing that we can look at real early. But that's not really part of this problem. We're going to solve it out the other way and look how it goes. So let me put my tea down 1 second. Let's begin this one. So, first thing about mesh analysis is we draw our meshes. Pretty self-explanatory there. We've got a mesh 1, I1, and I always draw them in the same direction. There's multiple ways to do this, but for now, let's just always draw them in the same direction. And then we're going to get another mesh up here, and call this one I2. Let's get another mesh down here, I3. Okay, so that's our first step. Draw our meshes. Next step, we're going to look at what's happening in this first mesh. And this is the V equals IR stuff that we were doing. Okay, Kirchhoff's voltage law. So at mesh 1, so that's I1, this is our first mesh. We're going to go around the clock and figure out what's going on here. So let's start with, if we start up here with our 6, let's just look at our I1. I'm going to pull that out. This is a nice little clean way of doing it. So I1 is going to be times which resistance? Remember, it's V, total V minus V minus V minus V. So V minus IR, IR, IR. That's one way to do it. This is another way to do it. Either way is totally sufficient, but this way might be a little cleaner. So we're going to look at I1. And we're going to look at all the ones in I1. We're just going to add them up. So 6 plus 2 plus 4. Nice and easy. And now we're going to look. Do any of these have it touch a second mesh? This one does not. Everything goes through I1. Cool. This one does. This is I2. And so this mesh is going backwards compared to this one. So you see, if we're flowing down through this resistor, this mesh is flowing up through the resistor. So this is literally the opposite sign. So this is going to be minus, and now we have our I2 times, and that's our I2 from here, times whatever resistors are being shared by these two meshes. And that's just a 2 ohm resistor. So it's done there. Do we have anything else? No. Let's go. We have our I3, and that's going to touch this current set by this, and we're going up. So this one's going down, this one's going up, so that's going to be minus. That's where the minus comes from. This is going to be 4. Cool. And then we're going to go back to, so we've taken this as positive, coming this way, so this one's going to have to be negative, so we do 18 on this side. Again, these are going to take a little bit of getting used to. You can also do the V18 minus I1 6 minus I2 I1 minus 4 I1 plus 2 I2 plus 4 I3, and that's the same equation as this. It'll come out the same. You're just flipping all of your signs as you do it. So it's just a different way of doing it. This is fine, so we're going to add this up. What do we got? 6I1, so that's 12I1 minus 2I2 minus 4I3 equals 18. We'll just write it down nice and easy. 12I1 minus 2i2 minus 4i3 equals 18. First equation done. Let's do mesh 2. Mesh 2. It's this one up here. Let's start this. So we're going to put our I2 down because that's the start of the mesh. Then we're going to put all the ones that touch I2, which is 2, 4, and 2. 2 plus 4 plus 2. Cool. That touches all of these. I like it. And now what are the ones touch this I2? Well, we have this one again. This is touching, and this is going, again, in the backwards direction. So this is going to be minus I1 times, and it's only touching in the 2, so we're done with that one. Cool. And then we've also we're going to do our minus, and we're also going to have the other one touching this one, which is our I3. So we're going to put I3 and our 4. Later on, we're going to see that this actually cancels out to 0. But for now, let's just leave it. I mean, we could keep it. We could not. Since it's 0 later on, it could come out now. But we'll leave it in there, and we'll kind of cancel this all out later on. Equals 0. Okay? And so let's simplify that out to minus 2i1, cool, plus, what is that, 8i2, cool, minus 4i3 equals 0. That's our second equation. Almost done with this one. Let's keep going. Mesh 3. Our mesh 3, we're going to do the same thing down here again. So we put our I3, which is the name of our mesh 3. We're going to do all the ones that touch that mesh, which is going to be 4, 4, and 4. So what is that? 4 plus 4 plus 4. And then we're going to do, what else? So now that we have this one, we're going to do what touches I1. And that's going to be negative minus I1 because it's going the opposite direction again. And then what are we going to do here? We got, what is this? This is a 4 in between. We got 4 done. And then what else touches I3? We've got this one up here with the 2. So this is going to be minus I2 because, again, this is going this way, this is going this way, opposite directions. And then this one is, again, another 4 equals 0. So the last equation we have is minus 4i1 minus 4i2 plus 12i3 equals 0. Boom. 3 equations, 3 unknowns. You know what that means? That means matrix time. Dun, dun, dun. So let's do it up here so we can see everything and get it all on one screen. See, I'm starting to pay attention to the screen now. So, I1, I2, I3, number. Okay, so this is going to be a nice chunky matrix there. And a nice chunky matrix there. Equals, and a nice chunky matrix out. Let's plug these values in and solve them. Same thing as we normally do now. So we got 12 minus 2 minus 4, 18. Minus 2, 8 minus 4, 0. Minus 4, minus 4, 12, 0. And A to the minus 1, B equals answer. And that's going to be 2, 1, and 1. And that is equals I1 because it's the first one. Equals I2, it's the second. Equals I3. Okay. So we got I1, I2, I3. Cool. So that's what our meshes are. I1, I2, I3. And again, if we look, this one going through this bit is going to be 0. Just because it's a balance on both sides. So I'm going to solve through this. Blah, blah, blah. That looks good. That looks good. Did I say anything? I think this is fine. Yes, this looks good to me. So I4. Another way of doing I4, just to prove out that it equals 0, we can do I4, which is the current going through that, is going to equal I3 minus I2, which means the current going in this direction minus the current going in this direction, because it's this mesh minus this mesh. And that's going to equal 1 minus 1 equals 1 minus 1 equals 0. That's another mathematical proof to be able to do it. So, cool. think that is pretty cool. I like that. Let's do another one.